I love the introduction. He calls me a strong woman. It's a strong woman. All right, so today I'm going to talk about policy as code and why I want to talk about that. That is one of the things I'm looking at right now as an innovation direction. And as some of you know, that I am an investor as my day job, although I started my career as a technologist. I'm very much still a sort of a technology person in mind. I run a security-focused venture fund called Rain Capital. I'm also sitting on a public board for a Fortune 500 critical infrastructure company. I am I'm a former board of director for OWASP, so that's why I'm here today, or one of the reasons I'm here. Here's my contact info if anyone wants to talk to me. So I'm not getting any feedback here. Am I still online? Can someone say something? Because I don't see anything either.
Oh, yes, it's good, good.
Oh, yeah, good. All right, so I'll keep going then. So one of the things that sort of inspired this whole thing about policy as code is, as everybody here knows, that DevOps is driving innovation in business, right? So we are a ton of automation is happening in the DevOps world. The build and test and deploy is a continuous pipeline that has a feedback loop associated with it, so that whatever you see in the runtime can come back to build and test again. It's an endless pipeline. And DevOps is driving automation, driving speed, driving time to market. However, security is a little bit lagging behind, right? And we got security folks, security teams, really got a lot of flack for it. And it presents a set of challenges for today's security team. The top one is there's a need for speed, right? So security controls that are heavyweight, that are kind of not agile, is going to be against the DevOps trend and DevOps grain. Also, security traditionally tends to be more siloed, not necessarily integrated with a dev functionality and dev pipeline. So here, security is often now being asked to collaborate more and integrate more. And there's also so the infrastructure as code coming in, and it's an unfamiliar sort of a component, an unfamiliar type of tasks that security has to get comfortable with. And really, this expanded role of developer that can directly touch production systems or touch production systems through an automated pipeline that is not controlled by security is really challenging the traditional mindset of security. So all these are coming at security teams as pressures, as challenges, and if we don't respond, if we don't change, then the conflict, if you will be amplified. And not only that, we're also looking at an accelerated threat landscape, right? So cyber losses in 2021 supposed to be $1 trillion, and it will grow very quickly to in 2025 to 10.5 trillion. And I think this is probably Gartner's number. When you're one side faced with moving fast, business pressure to move fast with DevOps, the other side you're faced with an accelerated threat landscape, security is sort of squeezed in the middle. What do? Security has to change the way we implement security, the way we work with other teams, the way essentially we do business. And one way to do that is move to code. And hence the whole theme of the talk is policy as code. And what does it mean to move to code? What is code, right? To implement something as code, really, let's say this thing you want to implement is it's a target, abstracted notion. To implement this as code, we essentially express this in a sort of programming language, which is code, right? We codify it, which is writing it in the programming language. And there has to be an infrastructure support, right? There has to be a way of parsing this language and implementing this language on the target system. And once you have that, what it allows you to do is expressing something as code and implementing it as code is you can now apply software engineering practices to the thing, whatever the thing is, across its life cycle, right? So you can now apply software engineering principles in design, in build, in test, in deployment, and ultimately management. And there's a lot of good things come with it. There's management at scale, there's explicit failure, there's testability, all that comes with it, which significantly reduces any manual work that you need to do if you were implementing this target as in the traditional manual way. An example of something expressed as code is infrastructure as code. Terraform, CloudFormation scripts, for instance, these have really completely changed the way infrastructure is delivered in a cloud environment. So these days, through the use of Terraform, a CloudFormation script, a DevOps team, or even a SRE or developer even could express the runtime environment or requirements for runtime environment through infrastructure as code, and then the cloud environment can interpret this code in runtime and put together dynamic resources to make the runtime environment as you specified. And as we have seen, this has really accelerated cloud adoption and cloud usage. The just go over a little bit more about the benefits of implementing something as code, right? So automation, speed is really management at scale. So now you can treat this thing the same way that you can control internet scale cloud. For security, though, if we're applying this to security, the as code concept, two of the major things for security that, in my opinion, is really important is now that you won't have silent failures you don't know about, because if you're expressing something as code, then you know what's not expressed. The exceptions should be explicit, and failures should also be loud and explicit. Silent failures and implicit exceptions are actually enemy to security. And expressing something as code or security as code would counteract that. So those two things are very important benefits. So implementing security as code, one of the starting point that I would argue is start with policy as code. Certainly in security, a lot of times we start with security policies. Without policies, we can't do anything, right? But how is policies implemented today? A lot of times it's manual, right? So we say, okay, should this team have access to these resources? There could be a team policy somewhere, but somebody has to pick up the phone and say, hey, let's let this team have access to these resources. And the IT has to figure out which applications to enable, which resources to enable access, and the credential has to be there and has to be provisioned, and then has to be tested. All that are manual work. With policy as code, hopefully this manual work can be eliminated to automation and to true engineering pipeline. So some of the example policies, before we talk about how that can be done, some of the example policies are, I put them in 3 categories. They're access policies. To the right is a lot of access policies can be expressed as code. And the examples are, all service accounts accessing this resource must be coming from a particular IP range, for instance. It's a very typical access policy. There are config policies, and a lot of times policies that we deal with are actually config policies. Some examples could be all S3 buckets should have default encryption enabled. It's a configuration option. Or all hosts should use this particular image. It's also could be a configuration choice. There another set of policies I call them governance policies. They're a little bit meta, a little bit more high level, not specifically about configuration or access. An example with that would be, for instance, all service accounts that are not active over a month should be disabled. Right? So, and that is a policy that could be expressed in code and then tested and implemented. Now, policy as code essentially means there is a language for which you write the policy, and there's the corresponding target platform for which the policy will be applied would have the capability to parse, to understand, and to enforce this policy. And then there's also the assumption that there's an engineering pipeline that, or you're able to build an engineering pipeline that connects authoring, testing of the policy with the deployment to runtime and monitoring in runtime to implement the feedback loop. Should something's not working in runtime, you need to change the policy. There's automatic feedback loop to the authoring part of it. And there's a way to change this policy dynamically, possibly automated. Then you can go through this whole author, test, deployment stages again to update the policy. A few building blocks that are needed for policy as code to be effective. This is actually a slide taken out of a recent report that I did. You have to have a policy, have a policy language, which is common framework and language. And here in the cloud world, OPA framework is a very popular one to author policies. So everybody has to agree on it, and it has to be a standard language. There has to be visibility, meaning that you kind of have to know what your environment is like. Otherwise, you cannot write policies, right? So you have to write policy to a visible environment. You have a way to test them, handling exceptions, and have a way in runtime to detect if they're not effective, and then have a way of remediate and respond to adverse outcomes or adverse conditions, and which means that this completes the whole engineering pipeline. This is just the pipeline that I talked about. So with the policy as code, you complete this circle, but as a circle, what's moving around the circle is actually security policy, not just application code. So you would do the same thing as you would do with application code. You would build it, you would author it and test it, and then you deploy, release into the production environment, and then you would monitor its operations, collecting data, and goes back, the data and results going back to the development stage, and maybe impacting the next version of policy, maybe you change a little bit, and then the policy goes back into the deployed environment again. So policies moving on this infinite 8 figure just as application code would be. Some of the characteristics, we need to keep those in mind. The policies have to be declarative. If they are not, then they cannot be expressed statically as code. So it has to be something that you could express before runtime. Also, I think the policy has to be open, not proprietary. Otherwise, then you cannot interoperate. So OPA, for instance, is an open framework, but on the receiving end, right, the target platform also have to have open capabilities to receive these policies. Could be through open APIs, could be through some kind of open standard where policies can be applied. It also has to be testable, right? So as code implies, it's testable, but we have to know how exactly to test the security policy as code, because the test condition has to be security related, not just any tests. And lastly, and in my opinion, one of the most important characteristics of policy as code is the failure condition has to be explicitly spelled out so that we know when things don't work. So these 4 things are the critical characteristics of policy as code. Some of the example, I'll give a very simple example here. There are certainly a ton of examples of policy as code. Let's say you want in runtime, find all the user accounts or service accounts that have access to a particular critical resource, and then completely change their access from what they have today to a dynamically controlled lifetime, right? A shortened TTL by giving these users and accounts a new dynamic access token with a short TTL so that you can re-authenticate them and control them. Now, the way to do that, for instance, these are pseudocode, so don't worry about the syntax. You are looking at all the data, across all the data you have, says, give me all the accounts that with the tag as the roles and policies that's accessing the critical sensitive resource that's tagged as critical and sensitive, and all the results. The query results are put into this list called list account. And then you do assign this temporary token that you've already created to list account. Looks fairly simple, but you will have to have a place to go query this information. You would have a place to say, hey, where's how to express the assignment relationship, where's taking the data into the list account, and then implement this operation of giving the temporary token to that list. And this is actually a live policy that's taken out of one of the policy as code product that I know that implements this kind of language. Once you have this, right, so an example like this, but there are many other policies you can express as language, is you can run this periodically and find everything you need and apply a remediation action. The biggest benefit, in my opinion, is policy as code offers really manageable and measurable security for the cloud environment. So security program now, not only automation management at scale, but you can measure it very precisely what the result is. Some of the folks who are doing innovation work in policy as code is here at the lower right. You can take a look at them. Some names probably known to you. Others are innovators in this space. I'm watching them. And why is this relevant for OWASP? I think I don't have a lot of time left, so I'm just going to quickly summarize why this is relevant for OWASP, because a lot of these security policies are about security ops, but why is it relevant for OWASP? Infrastructure as code now in organizations has already reached about millions of lines in sophisticated organizations are taking advantage of those cloud automation. Once we put securities code in place, how large do you think that will increase your code base? Everything is code now. Of course, as application security professionals, we should know how to test the code, how to manage the code through its life cycle. And all the SDLC principles that we've learned on application code should be applicable here with some tweaks, right? Because we're looking at the language syntax different. It's not as Turing complete as actual application code. So there's some things, the characteristics are slightly different, but a lot of the fundamental principles remain the same. And that is why it's relevant for OWASP. And in the industry, right, so I'm seeing as someone who's looking at early stage startups and emerging tech, we see a lot of securities are moving from silo to developer driven, and policies again is built into the dev and deploy pipeline. So, and it's happening bits and pieces, but if we take a step back, we're seeing the entire industry is slowly but surely moving to security as code and automation at scale. And beyond automation scale, we're seeing essentially across security, across IT, across ops, everything that can be automated should be automated. Everything cannot be automated is where human can add value. And this is where the state of industry is, and we're continuously seeing this envelope being pushed. Things were not automated before are being automated, and including security. Although I would say security is still kind of lagging behind in terms of the whole automation game, but securities code can help. So with that, I'm going to conclude my presentation. Here is my contact information, and please send me a question if you have, or connect with me on LinkedIn, follow me on Twitter. I'd love to hear what you are doing in security, and possibly you are doing something interesting, policy as code as well. So thank you.